In this part of the lesson, we'll cover forms of exponents, and we'll also cover how to evaluate them. First of all, the word exponent kind of has two meanings. One, a general meaning. When we say exponent, we mean this combination of both a base and an exponent. And then very specifically, when we refer to exponents, we're talking about just this piece up here. This is your exponent. And so this is the power that this base is raised to. So when we say raised to the third power, we're talking about 2 being multiplied by itself 3 times. And you'll remember that 2 times 2 is 4 times 2 is 8. When we talk about exponents, we also talk about them in forms. So we have exponential form, we have factor form, and we have standard form. In exponential form, we're just writing the base with the exponent. So this right here is in exponential form. When we write things in factor form, that's what we're doing here. We're multiplying and showing how we're multiplying that number by itself and the number of times. Then in standard form, that is the value. We have evaluated the exponent. So 2 to the second is 4. 2 to the third is the same as 2 times 2 times 2, and that is equal to 8. Those are the different forms of exponents. Now understand that the standard form really only applies to exponents that have a numeric base. If you've got a variable and it's raised to a power, that's not really going to have a standard form because x to the second is really just x to the second. You can't simplify it anymore. You can't evaluate it any more than that. So now let's take a look at some actual example problems for exponents. In this case, what form is this in? This is in factor form, right? So we have 3 times 3 times 3 times 3, and we're going to write that in exponential form. So that would be 3 to the 4th, 3 to the 4th. Then, if we were to write that in standard form, we'd simply evaluate 3 to the 4th. We look at its factor form and multiply that out. So 3 times 3 is 9, times 3 is 27, times 3 is actually 81. So 81 is the value of 3 to the 4th. Let's take a look at another example. 6 to the 3rd. Well, we can punch that in our calculator, I suppose, but we're not using our calculators yet. So 6 times 6 times 6. 6 times 6 is 36. Times 6 is actually 216. 216, and you can multiply that out for yourself to prove me right or prove me wrong. Let's take a look at some that are a tiny bit more complicated. So here we have negative 2 to the 3rd power. And at this point, it's really important that I explain to you the difference between negative 2 to the 3rd power and negative 2 to the 3rd power. Now, it sounds the same, doesn't it? Well, this is negative 2 to the 3rd power, but this is negative 2 to the 3rd power. We just don't write those parentheses in. Even though they're there, we don't write them in. So this, we're going to take the negative 2, and we're going to multiply negative 2 by itself 3 times, so that we would have negative 2 times negative 2 times negative 2. However, down here we would have the negative of 2 times 2 times 2. So those are two different things. What we're looking for is this one up here. So we're going to take negative 2, and we're going to multiply it by itself 3 times. Now I want you to notice something. First off, let's look at what the sign is going to be. When we multiply a negative times a negative, you'll remember from your integer rules that that gives us a positive. So negative 2 times negative 2 is going to give us a positive 4. Then we're going to multiply that by a negative 2. Well, that's going to give us a positive times a negative, which will give us a negative 8. So it's important to notice what your sign is going to be. Now let's look at the next one for an example. Over here, we have negative 2 to the 4th power. And again, they're in parentheses. So we're going to take that and we're going to multiply negative 2 times negative 2 times negative 2 times negative 2. And when we do that, we're going to take it step by step. Negative 2 times negative 2. 2 negatives give us a positive when we multiply. Then we're going to multiply that by a negative 2 right here. That's going to give us a negative 8. But then we're going to multiply that by the final negative 2. That has 2 negatives. That will give us a positive 16. So at this point, hopefully you're beginning to see a relationship. If we have an odd number, so if our exponent right here is an odd number, what we're going to have is a negative result, right? We have a negative here because anytime you multiply those out and it's an odd number, you're going to have a negative answer. If, however, this number right up here is even, if that's an even exponent, then you're going to have a positive result, just like you did here. So an odd number up here gives you a negative result. An even number gives you a positive result. Remember that, it'll help you a lot. Okay, last couple we're going to look at. These are special cases. So anything raised to the first power is always that same number. 5 raised to the first power is 5. 12 raised to the first power is 12. 256 raised to the first power, it's 256. Always the same. Remember that one. More importantly, remember number 6, because this one tends to throw people off. Anything raised to the 0 power is always 1. So 4 raised to the 0 power is 1. 12 raised to the 0 power is 1. 256 raised to the 0 power is 1. 4,783 raised to the 0 power is 1. Inevitably, some of you are going to ask me why, and that's going to require me to do a mathematical proof for you. So I can do that at a later time, but just trust me on this. Anything raised to the 0 power is 1. In fact, even 0 to the first power is considered to be equal to 1. I know what you're thinking. How does that happen? How do you get 1 from 0? How do you get something from nothing? We don't do magic. It's complicated, and mathematicians will argue about this one. But for all practical purposes, and certainly for everything we'll do in our class, and you'll do pretty much through any class that you take from here through high school, 0 to the first power is equal to 1. That's it.